In this video, I will be going to explain two assembly language programs of Embedded System Lab and three C programs of Embedded System Lab. In next video, I will explain another five .c extension files, means C programs. So for that, first we need to open the Keil software. In this Keil software, first step is to create new project. For that, go to project, new project. So for that, to create the new project, go to C drive, search for the Keil software, double click on it and select C51, double click on it, go into examples. Here we need to create new folder, so name it as Jyotish 1. Open it. So double click on this folder, it will be opened. In this folder we need to create a file with .a extension. So why? Because .a means we are typing the program in assembly language. So for that, jo.a extension and enter. So it will be saved. After this window will open. In this window we need to find the Philips and click on Philips and we need to select RD2. So here RD2 we need to select this one and click on OK. So after this will be open, click on no. So after these all steps, the target will be created and source group is created in this target. So after that, right click on source group, go into add files and go to examples. The file which you are created, Jyotish1, in that file .a extension file we need to search, select .a extension file and add. So this jo.a file is added into source group. Just double click, this window will be open to write the program. So first program is addition. So for addition, we need to copy the first program. So for the first program, it is an addition. In this program we are adding 10 times. So for that, copy this code and paste it in Keil window. So check whether the alignment is good or not. After alignment of this program, we need to save the program. Save the program. After saving the program, translate the file, build the file and rebuild the target files. After finishing these three, we need to go for debug section. In debug, start and stop debug section. After this, click on OK. Here the 3 will be added 10 times and the result of this program, it is stored in A, that will be going to the 30H memory location. So for that, after doing all this, we need to run this program. Run the program. Here we need to search for the 30H memory location. Here is a 30 memory location. The answer will be E4. The answer, it is in hexadecimal number. E4 is a hexadecimal number. When we add 3 10 times the 30, answer, when we convert 30 into hexadecimal, it is E4. So this is the answer. So after this program, we will go for last program, which is square wave and rectangular generation. That means timer 0 program. In timer 0 program, we are creating the rectangular wave and finding amplitude, time, t1, so frequency. So the procedure will be same. But finding the output is somewhat different. So just select all, delete. So now we are doing the last program, timer 0. For that, the manual code is not sufficient. So the code which ma'am sent, that we need to copy and try this program. This is a code for timer 0. Just copy the code and paste it in Tail software. Why? Because the first and the last programs are assembly programs. So that's why I am doing in same file. Okay. Next, after copying this file, just to save. So here the translate build rebuild, it is not shown, right? So just going to debug, start and stop debug. So now here they are visible. So just again save the program and translate, build, rebuild. After this, going to debug, start and stop debug section. So click on OK. So after doing this whole process, here we need to view the waveforms to find out the frequency and time. So for that, go into view. In that view, go into logic analyzer window. So it is a waveform stimulation window. In this window, go into setup, click on new or insert. Here we need to type capital P 1.5. So enter. The waveform will be set. When we run it, the waveform will be shown here. So just run the program. Here we will find the waveforms, right? Just zoom out for clear visibility. Okay, this is a rectangular wave generation in timer 0. Okay, so in this we need to find amplitude, time period and frequency. Zoom in. So just move the cursor here where the waveform starts and where the cycle ends. These two values we need to take, just where the cycle starts, where the cycle ends. Just for the one cycle we need to take the values. So for that, first we need to take the two values, t1 and t2. Subtract the t2 minus t1, we will get the time period. So after finding the time period, we need to find the frequency, that f is equals to 1 by t, right? So after substituting, we will find the frequency in hertz. So for this, the T1 will be 0.068 and T2 will be 0.10. So subtracting T2 minus T1, we will get capital T, that is time in seconds. So after that, F is equals to 1 by T, we will get the frequency. So now we need to find the amplitude. So this is a V minimum 0 volts and V maximum 1 volt. So VPP is 1 volt. So this is the output for the last program. Now we need to go for the second experiment, that is IO operations. So second experiment is IO operations. So what is the aim is to write a program in embedded to get a byte of data from P0 if it is less than 100, and this is second experiment, and send it to P1, otherwise send it to P2. That means if P0 is less than 100, it has to be shared into P1, otherwise it has to be shared into P2. That is the aim of this experiment. So just we need to copy this code, copy the code and go into Keil software. Here the second experiment is in C language. For that, the file which we are saved, it is in .a extension, right? So for that, the C language, we need to create a new project. Create. So just we need to stop the simulation and so again open the Keil software. Open new project in C drive, search for Keil. In Keil, click on C51, go into examples. In examples, we need to create new file. So in here, Jyotish 2. So open, double click on this folder and create jo2.c. So here we are creating C program file with extension of .c. Save. After this window will open. Click on Philips. In this Philips or D2, we need to select or D2. Click on OK. Click on No. So after this all process, the target and source file is get created. So right click on source file, add source file. So go into C15 examples, and in examples Jyotish 2, in Jyotish 2, this is the file with extension of C source file, right? So add this file into source 2. So the file is added here. Double click on it, the window will be open to write the program. So the code which you are copied, just we need to paste the code. After pasting this code, for to view the output, save, translate. So there will be error if I is sitting caps. We need to C is a case sensitive, we need to use a small I. So after this, save the file again, translate. There is no errors, zero warnings, build, rebuild, and go into debug section, start and stop debug section, click on OK. Here we need to go for the peripherals and add IO ports, port 0, port 1, port 2. Just drag and drop each port in good alignment. So why we are selecting port 0, port 1, port 2 means here P1, P0, P2 we are used, right? For that only port 1, port 2, port 0 we are selecting. So after this selecting the ports, we need to run the program. If you are running, if you change anything, any values, automatically P1, P2 stores the value according to the program. So when P0 is less than the 64 bit, what will happen? It will go and store into P1. If it is greater means it will go into P2. So it is greater, so that it is stored in P2. It is small, so it is stored in P1. When we decreasing, so it is smaller than 64 bits, so it is storing in P1. The change is occurring in P1 only. Okay, so this is the output. This is the output for the second program. So after this program, we will go for third program, that is IO operations with the delay. The program which is written in manual, that is not working. For that MAMS and code, so that code we need to copy and paste here. The procedure will be same for the all remaining programs, just we need to change the code, and according to that we need to add the ports and observe the output. Just go and search for that code. So having the delay program, this is the delay program which ma'am sent. Just right click on it, copy, paste. So we have pasted the code. Now just here it is not visible, right? So just go for the debug section, start install it. Now it is visible. So just save the code. Just save the code. Translate, build and rebuild. After that debug, start and stop debug. Click on OK. Now in this we used only P2 and P1 ports, right? So for that go to peripherals, IO ports P1 and P2. So if anything changed in P1, that it is automatically updated in P2 after delay of half second. So just run the program and check whether the output is coming right or not. So if you change P1 after delay of half second, automatically P2 will be changed. Just observe the output. So this is a third experiment output and program. After this, we will go for the fourth experiment, that is door sensor monitoring. So control A, delete it. So the process will be same, just we need to change the program. So we need to copy the fourth experiment. So door sensor monitoring. When the person is detected, when an object or person is detected in door, the door will be open or the buzzer will be on. Like that it will be operate in this door sensor monitoring. So for that we need to copy the code and paste it into Keil software. After pasting, save, translate, build, rebuild, go into debug, start and stop debug section, click on OK. Now we need to see the output. To see the output, here we are using only port 1. Go to peripheral, port, IO ports, port 1. When an object is detected in 1, that means P1 power of 1. This is the P1 power of 1. This is the P1 power of 7. So when the object is detected, so it will be 1, so that the door will be open, right? So this will be 1. When there is no object or no person, it will be off. Sorry, we are not run this program, right? So run the program. When the object is 1, when the output is 1, that means P1 is 1, the P7 is 1. When P1 is 0, automatically P7 is 0. That means when an object is detected, the door will be open. When an object is not detected, the door will be closed. Like that the program will be work. This is the output for the fourth program. Next we will go into fifth experiment, that is toggle switch. Toggle switch. For that we need to select all this program and delete it. So program which is in manual experiment 5, to write the program in embedded system to toggle all the bits of the port B parts continuously with an 250 milliseconds delay. So continuously we have to toggle the values, that means 0 to 1, 1 to 0. So for that we are using the port 1 only. Select, copy the code, and paste it in Keil software. So here we are pasted the code. So after pasting the code, so just stop and stop. Here it will be visible now. Now save the program. Just save the program and build, translate, build, rebuild, go into debug, start and stop debug. So click on OK. Now go to peripherals, IO ports, port 1. If you run, automatically it will toggle. So we will observe the toggling the levels after delay of 250 seconds. See, after some seconds it will be strucking, and after that it will be running. So like this the output will become. So after this experiment we are going for sixth experiment, that is blinking LED. So the code is same as it is in the manual, just we need to copy and paste it here. So go blinking LEDs. To write the program in embedded to perform blinking LEDs using Tail software. So just here also we are using port 1 as an output port. Copy this code and paste it in Tail software. After pasting, so here the translate is not locating right, just debug and stop debug. So here it will be visible now. Save the program. Translate, build, rebuild. In debug, start and stop debug. Click on OK. Now we need to see the output in port 1, right? So port 1. So when we run, port 0 will be blinking. Why? Because we are initiating only port 0. So continuously it is blinking. So this is the output for LED blinking, that is sixth experiment. So finally sixth experiment also over. After this experiment we need to go for the dancing LED. For that is also in the C program .c extension file only. The process will be same, just we need to learn the program. Control A, delete. So for dancing LED program, so same dancing LED using Tail software. Copy, copy the code, go into Tail software, just paste it here. After this, just save the program, translate, build, rebuild, debug, start and stop debug section. Click on OK. So to see the output we need to add port 1. So because of our peripheral, input output peripheral is port 1, which we need to observe the output here. So just run it, continuously blinking from 0 to 7. That is a program which we are written here. Blinking LED continuously. So this is the output we have to show. So next program is serial transmission. For that, just erase this program, go to manual, and so this is the aim of this program. We need to copy this code. This is simple. How serial transmission will occur in real-time data transformations. So just copy this code and paste it here. After this, so just save the program, translate, rebuild, and go to debug section, stop, and so click on OK. Now we need to observe the output. To observe the output, first we need to run the program and go into view. In view, go into serial window. So in serial window it is not visible. Check whether we are written the same, whether the program is saved or not. So again we can check whether there is any error or not. Just save the file and build. So here we are observing so many errors. I think this symbol will be wrong. We can change the symbol here, because we are copying from the manual, so that this will occur. Sometimes a small symbol will be damage whole program. So these are the strings SVCET. So after this, save the program, just translate. There is no errors and no warnings, right? Check first any program we are running whether the errors are there or warnings are there. So after that, build, rebuild, go into debug and start and stop debug section. Click on OK. Now we need to run the program. After running the program, to view the output, go to view section and go to serial window. So the serially data will be transmitted continuously. This you will observe here. SVCET, SVCET, SVCET. So many times it will be go on. So just stop the simulation. This is the output how we have to show for the serial transmission of data. Next, last but not least program, that is serial reception of data. For that, just we need to select all, backspace. So go the program which is provided in manual, it is not sufficient. For that we are selecting the program which MAM sent. This is the program which we need to copy. After copying, paste it in KL window. After this, okay, save the program. Build, rebuild, debug, start and stop debug section. There is no errors. Okay. So to view the output, just we need to run the program. Go to view section, in that serial window. Go to view section, serial window. We are not finding any output, right? The output which we are giving through the keyboard, that will be showing serially. So when I am typing J Y O T H I S H, so the reception of data will be serial manner. So this is the output for the 10th experiment in our manual. So finally we completed Then next meant how to see the results and how to manage the tool, the process which you are doing for the execution of program. Thank you. Thank you so much.